All right, in WordMatch, we're writing code with this string guess given to us. And then we've also got string secret. And a couple little things like they promise us the guess length is less than the secret length. They promise us there's no empty strings. Okay, so we don't have to really worry about any weird stuff going on. Ultimately, it's a counter method. We're going to count how many times that occurrence is in there and then multiply it by the square of the length. So when we're ready to return in this problem, we're going to take the counter and multiply it by the guess length times the guess length. So at some point we'll want to set up a counter, initialize it to 0. You might even want to go ahead and just set up a guess length so you don't have to keep writing guess.length over and over. And then at the end of the problem, we're going to return the counter times the square of the guess length. All right, now on this counter, I've shown you like two ways to do it. A for loop where you take a substring and an equals method and you count the occurrences. Or we've also done it using the index of method, which if you're going to do that, I really recommend you write a while loop that's also based on the index of method. But if you put the index of method inside of a for loop, it's not impossible, but chances are it's not going to work the way you think it's going to work. And so I don't recommend that. I will show you two ways to do this problem. So in one way, I'm going to start with a for loop. And, typically if I'm writing a for loop to go across a string like secret, I just go right up to the length, one index at a time. I'm probably going to change that though, because that for loop's really set up for taking a one-letter substring. So take secret and substring it I plus 1. That would work great. The problem is like if they give me a 3-letter guess, I need to do 3-letter substrings within that secret string, looking for that 3-letter guess. So it's really not safe to just put 1 there. I want to put G there, or the guess dot length in place of that. So if that's 2 or if that's 3, then that's how many letters I'm going to get from that substring. Now think back to when we were first learning about strings and loops, like chapter 4. We did a lot of Java bats. At first, I encouraged you to write whatever that larger quantity in the substring was and not let it go past the length of the string. A lot of you have changed how you write loops since then, but pretty consistently, we used to all write them the same at the start. And remember, substring's a little different. Like if you have an array or an array list and there's 10 items in it, you can't go past index 9. Like that's the last one. And if you tried to go to index 10, you'd go out of bounds. But if I have a 10-letter string that's indexed 0 through 9, I can actually substring to 10, and it doesn't go out of bounds because of how substring doesn't include that second number there. It goes just up before it. So this is totally fine. I can go up and equal that, but I can't go past it. Once I've got that loop and the substring set up, it's pretty easy from there. I just ask if sub equals guess. I've already got all the other math components set up here, and so I'll just go ahead and increment my counter, and that should do it. Make sure to check the values you're getting, because you have to have these values right to get part B right. Okay, that's not true on an actual AP test. You can get part A wrong and still get part B right, but just in our simulator here, we have to have it. Those are the correct numbers. Those are the same numbers coming out of here, 4, 18, 36, 121, and so on. And I see them coming out here in the same order. All right, so that's one way to do the problem. I said I'd show you another way. Okay, so let's turn off that for loop. And what if we wanted to do index of? So we would take secret, we'd run an index of on it, and we put the guess in there. As long as we don't get -1, then the guess string is in there, and we should go ahead and count it. But if I just stopped right there, it'd be an infinite loop. I just keep counting it over and over and over, so I don't want to count it again. And unlike a for loop that would just maybe move from index 0 where the M is to 1 where the I is, that doesn't really work here because like an index of method kind of jumps around on its own. It might jump from index 1 to index 4 to index 7. And if my for loop's just going like 0, 1, 2, 3, I might end up counting the same thing over and over. What I really want to do with index of is I want to remove the occurrence that I just found. I could just take it out individually. I could take out all the letters up to and including that first letter. But I need to actually take it out of there so I don't find it again. It doesn't really say it in this problem's directions, but it's never a good idea to start destroying an instance variable. It's in our notes, so like it is something that it's almost like somebody maybe could even get penalized on an AP test without the directions explicitly telling you not to. So what I would do here is I would make a copy of that string and I would use it. And then what I'll do is I'll destroy the copy. I'll say copy is a substring of itself, and I'm going to base that substring off of that very same index of, but I'm going to add 1 to it to go 1 index over so that I don't find the same substring again. Like if I was finding ISS in Mississippi, I'm going to take away up to and including the I. So I can't possibly find that occurrence of ISS again. Okay, and then if I run it from here, let's see what happens now. Those are the same numbers, so everything's good. I like both these answers. I'm not saying one's better than the other, but just what you don't want to do is like try to combine the two. So don't try to put like the index of statement into the for loop and expect it to work. These two loops have two different control expressions. So if you're going to use an index of, I think you want to use an index of control expression, not a control expression that's just going one index at a time. That sets up better with a substring and an equals method. Okay.